my Algebra 2 friends, we're back, and we're going to do more exponent properties, because what would make an exponent property problem better? By throwing in some fractions. So 6.1 is going to seem really familiar because we just worked with these same properties, but today a lot of our exponents will just be rational, which means fractions. Now, I don't want you to panic about the fact that they're fractions. I'm going to show you how to do them by hand again, but if you're like, yeah, it's not worth your time, or maybe you're not accurate enough. When it comes to crunch time on a test, if you have access to a calculator, please, yes, do use the calculator to simplify the fractions. The reason, we're going through them without the calculator today is because a large portion of your SAT test, or possibly your ASVAB if you're going into the military or some other testing, they require you to do these basic skills tests without a calculator. So while, yes, you technically know how to do fraction work, it's been a while, so let's practice it. So these same properties that we saw in the last lesson, when you have the same base and you're trying to multiply them together with exponents, you keep that base, but you add the exponent, right? That trigger word there. So here's an example, and it's already done for you. So 5 to the 1/2, these powers got a little weird. They're supposed to be way up in the exponent position. So 5 to the 1/2 times 5 to the 3/2, we're supposed to add those together. Just to remind everybody, when you add fractions, you need to have common denominators. This one already had a common denominator of 2, so this is really a 4/2 as an exponent. We know 4/2, better known as a 2. That's where this came from. And then 5 squared is 25. So if you have a numerical example like we do here, you're supposed to take it all the way to the best answer you can get. So keep that in mind. Of course, ours today will be a mixture of algebraic and numerical components. So when you have a power on top of a power like this one here, you are supposed to multiply. Can't write straight. I don't know. So the example they gave you here is where they multiplied these exponents together. It's simplified to a 3 to the 5th power now, which is something that you could either use your chart for, or a calculator, or your brain from memory. When you have a multiplication problem that has a power outside of it, this is where we distribute. So that's what they did at this problem. And we're going to learn in our next lesson that the 1/2 power is the same thing as the square root, but maybe you would have typed that on your calculator if you didn't know today. 16 to the 1/2 is 4, 9 to the 1/2 is 3, and of course 4 times 3 simplifies to a 12. Oh boy, the negative exponent rule, remember, just simply means to move. Anything with a negative exponent is going to move to the other side of the fraction bar. Now this problem becomes a little more complicated because there's like a fraction bar that kind of inherently exists in the problem right here, but then there's also a fraction exponent. So when I say like move the fraction, that can get a little confusing. So any exponent that is negative is going to move to the other side of the term, I should say, is going to move to the other side of the fraction bar. So it does get confusing. I even made it more confusing just now. So the 36 with a negative exponent is going to move to the other side of the fraction bar, so it moves down to the bottom. Now it's a positive exponent, and then you can figure out that 36 to the 1/2 power is really a 6. So the answer is 1/6. All right. If you're dividing the same base with exponents, then you're going to subtract your exponents. Remember that, and you know what? I kind of keep forgetting to talk about how we do this fraction work in our head. When you're adding and subtracting fractions, you need common denominators. Now, this example I gave you already has a common denominator, which is lovely. So this becomes a 4/2 up in this new exponent. Hello, vocab girl. 4/2, also known as 2. So that's where this came from, 4 squared. And we know 4 squared is 16. All right, this is another question where this time it's a division with an exponent outside of it. So we're going to distribute that exponent again. And then, of course, simplify as necessary. So distribute. We'll learn in our next lesson, the 1/3 power is the same thing as the cube root, and that's why these are simplifying so nicely. And then anything to the 0 power is equal to 1. Hello. Anything to the 0 power equals 1. So like right here. This is anything, right? Anything other than 0, I should say. Anything to the 0 power is equal to 1. It doesn't matter how ugly it is, guys. Anything to the 0 power besides 0 is 1. Okay, so here goes the fun part. We're going to use our properties. Here we're told that when you multiply the bases together, we are to add the exponents together. So this becomes x to the, now this is where kids are like, oh no, you are welcome to go reach for your calculator right now, and you can just type 5 divided by 2 plus 1 divided by 2 and then math enter if it's a fraction, and that's fine. I'm not going to judge you, but that's not going to help you on any sort of standardized testing where they do take that calculator away from you. So you need common denominators in order to add this together. It already has common denominators. So this is now really a 6 over 2. We know that as a 3. So the final answer is x to the third power. That's the simplification for that one. Oh boy. All right, so this is that problem where you have to distribute the exponent. And then because this one already has an exponent on the term, we're going to also have to multiply those together. So the 3 is just to the 1/4 power. And I'm not going to make you guys do anything weird with like coefficients like that. Just leave it. But the x, his exponent here, we're going to need to multiply these together. So up in his exponent, and these are your notes, so I think it'd be worth it for you to write this down, you are multiplying 5 over 2 times 1 over 4. Now without a calculator, when you go to simplify this 5 over 2 times 1 over 4, you could simply just multiply across the numerators and denominators and then simplify later, which is fine. But if you see any cross cancellation, you might want to look at cross cancellation. This problem doesn't have any cross cancellation. So I'm just going to multiply across the tops, the numerators, and the bottoms, the denominators. And that becomes 5 over 8. And that's his new exponent. That's it. So I didn't change anything with the 3. So it's 3 to the 1/4 power. And then now it's x to the 5 over 8 power. And that is your simplified answer. Those same 3 rules from the last lesson apply here. No parentheses. Everything has to be combined as far as like bases go. And no negative exponents. Once you've satisfied those 3 conditions, you're good. Ew. Okay. First issue is we have coefficients, which aren't even exponents. So these are coefficients that we just simply need to reduce. Just like you would do a fraction back in 5th grade, reduce the fraction. So you can math enter this on your calculator. You can type 12 divided by 8 and hit math enter, or you can cut each of these by a 4. So if you divided each of these by a 4, that would be a 3 and a 2. So your new reduced coefficient is 3 over 2. And then it gets a little weird. All right, so especially if I cross the problem off, we're supposed to subtract the exponents for the x's and also for the y's. Ooh, so here's what I'm going to write down. I'm going to write down in green x to the, and then his exponent is 5/6 minus 2/3. And then the same thing's going to happen for the y's, but his exponent is going to be 7/3 minus 2/5. We cannot subtract fractions unless they have the same denominator. That is a bummer. All right, so when I look at this green question, they would have a common denominator. The first one they'd have in common would be a 6. If you happen to multiply them together, you do that thing, and you got an 18, it's okay, it'll work. You're just going to have some reduction. If you're already working in your head, you want to give yourself the least amount of mental math as possible. So in order to create this to be a denominator of 6 parts, you would multiply it by a 2, but you got to multiply both top and bottom by 2 because that creates that fraction to have the same value. Like 4 over 6 is the same non-reduced version of 2 over 3. So that problem is now a 5 over 6 minus 4 over 6, which, ladies and gentlemen, that is a 1 over 6. So that's the new exponent on the x. I know some of you are like reaching for your calculator right now. You're like, hey, I don't want to do that. I understand. I'm just trying to get you ready for the SAT, okay? So same idea here. I need common denominators. This time we got a 3 and a 5, and the first number they have in common, their least common multiple, is actually a 15. So you end up multiplying them by each other, if you want to think of it that way. So this guy gets hit by a 5 over 5, and this one would have to be multiplied by a 3 over 3. So this fraction, this one right here, becomes a 35 over 15. This fraction is a 6 over 15. And that's beautiful. That is a 29 over 15. Now, when you typed this original problem in your calculators, 7/3 minus 2/5, you have to hit math enter for it to come back to a reduced fraction for you. Just keep that in mind. But there is no shame when you guys are practicing this of trying it in your head or on paper and then checking it on the calculator. I think that would be really, really bright, especially if you're going to go into the military and you need to get a good score on your ASVAB so you can get the job you want. Oh, my favorite property. Anything to the 0 power is a 1. So this whole numerator here is just a 1. Now down in the denominator, we're going to use that property, and that's a little negative symbol right here, so be careful. If I'm trying to multiply these bases together, I'm going to add their exponents together. So 1/3, and I'm adding to that a -5/2. Ooh. Now, this is going to get weird. I'm going to write my answer down here. We'll talk about what happens next, but I'm going to put an X down. Now I got to do my magic with common denominators. I have a 3 and a 2, so my common denominator is a 6. This guy right here would be multiplied by 2/2, and this guy right here would be multiplied by 3/3. So again, this could totally be done on your calculator. No shame in doing this on your calculator. So we have a 2/6, and then I'm not going to say plus negative. That's really weird. I'm just going to say subtracted. I think that says 3, so 15/6. And 2/6 minus 15/6 is a -13/6. Can't leave my answer like that. There's a rule out there that says anything with a negative exponent can't stop. It's got to move. So this term of x is going to move up to the numerator. It's going to be positive now. I don't need a 1 in front of it, so I'm just going to lose the 1. And my final answer is x to the 13/6. And I can already hear what you're going to ask me, Mrs. Abruzzo. What if I moved this to the top and then I subtracted them? Awesome. That works great. I have a feeling I just messed up that whole question, though. I'm going to go back and double check my work later and be like, 3, 15, 2, I think I'm okay. All right, moving along. Apologies if it's wrong. I don't have a calculator. Even I check these on my calculator, just so you know. Okay, we got some distribution to do. And while we're at it, I learned my lesson from my last lesson. Literally, the last lesson. If you can simplify what's inside first before you start distributing things, you're going to have less work. So like right here, I have y to the 3rd over y to the 1st. I could subtract these and reduce that to a y to the 2nd. I'm going to have less work in the long run. I think that's a great idea. So we have x to the 3/2. And then now it's just y to the 2nd. There's no more denominator because I simplified. And then this is all being raised to the 1/4 power. So we're going to distribute this. I really wish I had better handwriting. That is really unfortunate. Okay, 3/2. Like that's better. Okay, so remember this time we're multiplying these exponents together. When you multiply exponents together, there's no common denominator work happening. You could just multiply across the numerators and denominators. So a little sidebar math here, guys. You got a 3/2 times a 1/4. And then we're going to have a 2, which is like a 2/1, times a 1/4. So let's think about what would happen here. If you multiply it across the numerators and denominators, this one would be a 3/8. And this one would be a 2/4, which is going to reduce to a 1/2. Now, just thinking about 5th grade again, do you remember this called cross-canceling? The 2 and the 4 can both be cut by a 2. So that's what it means to reduce and cross-cancel before you throw everything into the numerator and denominator. When you're a small child who doesn't have access to a calculator, it's easier to cross-cancel before you smush the numerators and denominators together. Either way, we're good. Here's our answer. We've got x to the, I just did the work over here, right? Is this guy? 3/8, and then it was y to the 1/2. Order doesn't matter, of course. But make sure you have the right exponent on the right base. That would make a big difference. And once again, oh my goodness. You know, the reason I record lessons in the summer is because I've got to remember how to write before I see you kids. Hey, I think that was the last question. And I still can't write. So obviously this lesson is contingent on your understanding of the previous lesson. So if you feel like, man, the issue I'm having is just the properties themselves, they're not natural to me, go back and practice the stuff that aren't fractions first. Get a really good handle on that lesson. It's called Properties of Exponents. and then come back to this lesson. The added value of it being a fraction just makes your arithmetic more fun. It definitely doesn't change the algebra. People out there on the internet who are not from my class, there are some other rules about exponent properties where you're not supposed to have a fraction exponent in the denominator. Well, yeah, you're really not supposed to have a fraction exponent in the denominator. At our school, we don't worry about that rationalization rule. You need to ask your own teacher, though, if you need to focus on that. But if you're an Abruzzo kid or a Harlem kid, we're good. All right, good luck, everybody.